Okay, some theorems on measures of dispersion. Now, first theorem. First theorem, theorem 1. For any two observation, the standard deviation is half of the range. Proof. Proof. Let x1, x2 be any two observation. Any two observations. So mean, what will be mean? Mean x bar will be what? X1 plus x2 divided by 2. Okay. We know standard deviation s equals to what? S equals to formula what?
Root over 1 by n summation of
Square root over 1 by n summation I equals to 1 to n xi minus x bar whole square. Okay. So for if n equals to 2, s equals to can be written as s square equals to what? 1 by 2 summation I equals to what? 1 to 2 xi minus x bar whole square. This equals to what will be? Half summation, no need to take summation, x1 minus x bar whole square plus x2 minus x bar whole square, third bracket. So this equals to half x1 minus x bar means what? This is equation number 1. X bar means what? x1 plus x2 divided by 2 whole square plus x2 minus x1 plus x2 divided by 2 whole square. So after this line, we can write here, just taking LCM 2 here, this equals to half, what will be? 2x1 minus x1 minus x2 divided by 2 whole square plus x2, 2x2 minus x1 minus x2 divided by 2 whole square. This equals to what? Half x1 minus x2 whole square divided by whole square plus x2 minus x1 divided by 2 whole square. That means half into 2 into x1 minus x2 whole square. So this equals to what? S square equals to what? This one. So S can be written as x1 minus x2 absolute value of this. That means half of the range. For any two observation, the standard deviation is half of the range. Okay. Okay. Now another theorem, theorem 2. The standard deviation of n natural number is square root of r n square minus 1 divided by 12. Okay. That means you must know what is n natural number. Starting from 1, 2, 3, comma, dot, dot, up to n. Proof. The n natural numbers are 1, 2, 3, up to what will be n. Therefore, their mean x bar what will be 1 plus 2 plus 3 plus dot dot up to n. How many numbers here? N. Okay, this is the arithmetic mean. So this is this series. You must know what's the sum of the series n into n plus 1 divided by 2, another n here. So we get n cancelled, n plus 1 by 2. This is the arithmetic mean of sum of n natural number. Now sum of squares of n natural numbers. You must know sum of xi square. That means x1 equals to 1, x2 equals to 2, x3 equals to 3, dot dot up to xn equals to what will be? I equals to what will be? Up to n. And this means what? Actually 1 square plus 2 square plus 3 square plus up to plus n square. You must know sum of squares of n natural number what? n into n plus 1, n plus 1, twice n plus 1 by 6. Therefore, x bar equals to n plus 1 by 2 is equation number 1. And this is equation number 2. The sum of the squares of n natural numbers. We know standard deviation formula s equals to what? Square root over summation xi square divided by n minus summation xi by n whole square. This is the formula. That means s or s square equals to what? S square equals to what will be? Summation xi square divided by n minus x bar whole square. This is the x bar mean. So summation xi square means what? Sum of squares of n natural number. What will be the result from equation 2? N into n plus 1 twice n plus 1 by what? 6 minus x bar means what from equation 1? N plus 1 by 2. Okay. So you get this one. Here, sorry, this will be the like this. So here n and n will be cancelled. So n plus 1 will be common. And there will be square. Okay. So and n will be cancelled. We get n plus 1 twice n plus 1 by 6 divided by 4. After this line, we can write s square equals to n plus 1 will be common. N plus 1 will be common. Then we get twice n plus 1 by 6 minus n plus 1 by what? 4. We can take 2 also common, divided by 2. That means we get 3 here and we get what? 2 here. So this equals to n plus 1 by 2. Taking LCM, 6n plus 3 minus, sorry, this will be what? 4n plus 2 thrice n minus what will be? 3. N plus 1 by 2 into 4n minus thrice n what? Only n. Plus 2 minus 3 will be minus 1. Divided by what? 6. That means a plus b into a minus b what? N square minus 1 by 12. So this is the s square. Therefore, s square equals to n square minus 1 by 12. So standard deviation s equals to square root over n square minus 1 divided by 12. This is the result. Very easy findings. That means a standard deviation of n natural number is square root over n square minus 1 by 12. Very easy. Okay. First of all, taking some n natural number, then taking their mean and taking their sum of squares. Then putting these values in the standard deviation formula, we get the required result. Okay. So theorem number 3, if x bar and s be the arithmetic mean and standard deviation respectively of n non-negative observations, then x bar into root over n minus 1 is always greater or equal to s. S means standard deviation and x bar is arithmetic mean. Okay, now we are trying to prove this one. So let us consider, let x1, x2 up to xn be n non-negative observations. Okay, there are n number of observations. So x bar equals to what will be? Summation xi divided by n. Okay, where I equals to what? Where I equals to 1 to n. Therefore, which implies summation xi I equals to 1 to n. What will be? N x bar. Okay. This is equation number 1. Again, standard deviation formula you must know. S equals to what? Root over I equals to 1 to n xi square divided by n minus summation xi by n whole square. Okay. One by 1 by n. That means this you can write s square equals to 1 by n. Okay. So from this line, we can write, this is the standard deviation formula. We can write ns square equals to what? Ns square equals to summation xi whole square minus what will be? This one. Just taking n common, we get ns square. Or multiplying by n on both sides, we get this one. This is another equation. Equation number 2. Now we must know summation of xi equals to 1 to n whole square equals to I equals to 1 to n summation xi square plus summation xi xj, where I is not equals to j up to n. That means this means what? A plus b whole square types. Okay. So a plus b whole square formula what? A square plus 2ab, twice ab type this. So we can write this whole square equals to individual square plus xy term. That means xi xj, where I is not equal to j. Since xi are non-negative, non-negative means always greater or equal to 0. So summation xi xj always non-negative. Okay, where I is not equal to j. Okay, this term will also non-negative. Hence this line can be written as summation I equals to 1 to n xi whole square always greater than, because this is non-negative, so this whole will be greater than this. That means this value is greater than summation 1 to n xi whole square. We can write this because this is positive, so this plus means what? This greater or equal to. Now subtracting I equals to 1 to n xi whole square. That means xi, not whole square here. This whole square minus summation xi whole square by I equals to 1 to n whole square by n greater equal to summation I equals to 1 to n greater I equals to 1 to n whole square by n. Just subtracting this term from both sides. Okay. So actually this term and this term we can take common. Okay. This term and this term same, so taking common we can write 1 minus summation I equals to 1 to n xi whole square will be common, then we get 1 minus 1 by n greater or equals to, this is the actually formula of ns square from equation 2. Formula of what? ns square. And from formula 1, this is the formula of what? After this line, this is the formula of what? Nx bar. Nx bar into n minus 1 divided by n greater or equal to ns, or nn will be cancelled. X bar n minus 1 greater or equal to ns. Sorry, nx bar, there is a mistake. This summation, we can write n into n minus 1 divided by n, and this means what? Actually whole square, nx bar whole square. Okay, nx bar whole square greater or equal to, this is the ns square. From 1 and 2. Okay, from equation 1 and 2 we get this. So this means what? N square divided by n means what? N minus 1 x bar whole square greater or equal to ns square. Dividing by n on both sides because n is non-negative, and taking a square root, we get this one. Okay, proved. Dividing by n on both sides and taking a square root on both sides. Okay, this is the result. Okay, in this theorem, we have to prove an inequality x bar into root over n minus 1 greater or equal to s. That means a standard deviation. So let us consider x1, x2 dot dot up to xn be non-negative observations. So their arithmetic mean x bar will be what? Summation I equals to 1 to n xi divided by n. Just cross multiplication, we can write sum of all xi, all observation will be n into x bar. This is equation number 1. Again, we know from standard deviation, from the definition of standard deviation, s square equals to this. So multiplying by n on both sides, we can write this one. Just this n will be absent because multiplication, and there will be 1n. Okay, n square will be decreased to 1n. So this is equation number 2. Now we know sum of all square, sum of all whole square equals to, can be written as summation I equals to 1 to n xi whole square plus summation xi xj, where I is not equals to j. We can write this whole square like this because we know this is the a plus b whole square. A plus b whole square equals to what? A square plus 2ab plus a square plus b square plus twice ab. So for two observations, we can write sum of squares into sum of what? A into b, where a is not where I is not equals to j. That means suppose x1 equals to I equals to 1 and j equals to 1. So x1 whole square, this will be here, and I equals to 2 and j equals to 2. So this will be where? Square in this. x3 whole square will be this. So where I equals to j, this we get this square, but where I is not equal to j, suppose x1 and x2 and x2 they are absent, so here present. So x2 x3 x4 x5 x5 x6, Like this term will be like this one, sum of this one, and square will be this one. So we must know all observations are non-negative. That means greater or equal to 0. So their product will be always non-negative. So if this equals to this plus this, so we must can write this greater or equal to all this one. Okay, greater or equal to, this is the greater or equal to, because this equals to what, this plus this. But this, since this is non-negative, so this always greater or equal to what, summation xi equals to I equals to 1 to xi square. Okay, because this is bigger than this. So subtracting from both sides, summation xi by whole square by n. Okay, subtracting from both sides of this inequality, we get taking common, we get this one. But here this is the formula of what, equation number 2. Just putting equation number 2, we get n square. And here this term can be written as from equation number 1. Okay, from equation number 1, nx bar. Okay, so nx bar whole square. Okay, and n square by n, what will be only n, and n will be divided by dividing by n on both sides, because n is non-negative. So n is positive. Okay, positive n. This is why dividing by n on both sides, we get this one. And this is our required proof. Very easy for you if you do practice. Okay, another theorem. This is very important theorem for you. Mean deviation is the least when the deviations are measured from median. Okay, the mean deviation is the least. We have to prove that mean deviation is more and more less when the deviations are measured from median. When we measured the deviation from median. Okay, now proof. Let n equals to proof. Let n equals to 2p, twice p, be the number of observations. Number of observations which are arranged in x1, x2, dot dot xp, xp plus 1, dot dot up to what will be xn. Starting from x1 and ending with xn, and divide it into two parts, because n equals to twice p. So median ME lies between, this median will lies between what? Between xp and xp plus 1. That means xp less equals to a median less equals to what? Xp plus 1. Okay, median will lies between these two observations. Let a be the arbitrary value. Arbitrary value means what? Assumed mean. Value less than ME. Okay, less than ME and lies between what? Xk and xk plus 1. Okay, where k less than where k less than p. Remember it. That means a is less than what? A is less than median. Remember it. Let d1, d2 be the absolute deviations. Absolute deviations from median and a. Okay, respectively. Okay, that means d1 can be written as deviation from what? Median. So we can write d1 equals to me minus x1 plus me minus x2 plus dot dot plus me minus xp. Sorry, first of all xk plus me minus xk plus 1 plus dot dot xp me minus xp plus dot dot what will be plus me xp minus me plus xp plus 1. This will be xp plus 1 minus me xp plus 2 minus me plus dot dot what will be xn minus me. This is equation number 1. This is the d1 deviation number 1. Now another d2 will be what? Similarly, subtracting from what? A minus x1 a minus x2 plus dot dot what will be a minus xk plus xk plus 1 minus a plus 1 minus a plus dot dot xk plus 2 minus a plus dot dot xn minus a plus dot dot xn minus a. K plus 2 say plus dot dot x p xp minus a xp plus 1 minus a plus xp plus 2 minus a plus dot dot xn minus a. This is equation number what? 2. Equation number 2. Actually, median lies between xp and xp plus 1. Okay, this is why median lies between xp and xp plus 1, me minus xp, but xp plus 1 minus me. Okay, remember it. This is the p plus 1, because a median lies between xp and xp plus 1. All are me minus, but after this xp plus 1 minus. Okay, because a median lies between this. Again, arbitrary value lies between what? Xk and x plus 1. So a minus 7, then a minus xk, but xk plus 1 minus a. Okay, because xk plus 1 what? Greater than a. This is why. Remember it. Now, from equation 1 and 2, equation 1 and 2, d2 minus d1, that means subtracting what we get actually, a minus xk, a minus median into what will be xk k minus p minus k, into a plus me. Here a is the arbitrary value and m is the median, plus twice xk plus 1 plus xk plus 2 plus dot dot up to xp. Up to xp plus p into median minus a. So this equals to can be written as 2 into xk plus 1 minus a plus xk plus 2 minus a plus dot dot xp minus a. But which is positive quantity? That means this must be greater than 0, which is positive quantity. That means so d2 minus d1 will be what? Positive. That means their difference always give a positive quantity. So we can say that the mean deviation is the least. Mean deviation is the least when the deviation are measured from median. If we measure from median, then the deviation is the least. That means their difference d2 is the greater than d1, but d1 was measured from median. This is why mean deviation is the least when the deviation are measured from median. So this is the proof. Okay. So in from equation 1 and 2, if we observe, this is the first term, d2 minus d1 for the first term only. A minus x1 minus this minus this will give what? A minus me. x1 will be cancelled. Similarly, x2 will be cancelled, x2 will be cancelled. In this way, how many terms we get? A minus x1 k terms, because there are up to k, me minus xk, up to this term and this term. If we find the subtraction, then we get a minus me into k. Then for the rest term, we get what? This minus this term minus this term. That means xk plus 1 minus a minus me minus xk plus 1. So minus a minus me, what will be? If we take minus common, then we get a plus me. and in every term we get a plus me. That means assume mean plus median. So how many terms will be here? Because k term was what? A minus me. So rest of the term, that means total term what? P. So P minus K, the rest of the term will be P minus K into how many times? A plus me. So then after this one, this subtraction, we get another part 2 into xk plus 1, xk plus 2 dot dot up to what will be? Xp. Okay, up to xp. Then for the rest part, we get P into me plus me minus me. Okay, me minus me. So this, from this term we get 2 into xk minus a, and xp minus a, and this must be what? Positive, must be positive. If we take common k here, then median will be cancelled. Okay, so this term and this term will be cancelled, so we get only this term, and this term will be positive. So d2 minus d1 is positive. So the mean deviation is the least when the deviation measured from median. Okay, from median, where median lies between xp and xp plus 1, and arbitrary value assumed mean lies between xk and x plus 1. Very easy, but if you do practice. Okay, now next one, last theorem of the day. Find the mean deviation from mean and standard deviation of the observation like a comma a plus d comma a plus twice d dot dot up to a plus twice and d, and prove that the latter is greater than former. That means what? Latter means what? Standard deviation is greater than mean deviation. We have to prove this one from this. So how many observations here? Actually there are twice and plus 1, twice and plus 1 observations. The total number, the total observation, equals to what? Twice and plus 1, because for n equals to 0, for n equals to n equals to 0 first term, n equals to 1 second term, in this way. Okay, there are twice and plus 1. Their arithmetic mean, x bar with arithmetic mean, x bar what will be? Just adding a plus d plus a plus twice d plus dot dot plus a plus twice and d, last term. Okay, and first term, second term, third term dot dot, this is the last term. So how many terms here? Twice and plus 1, dividing by twice and plus 1, we get what? Then this equals to, can be written as what? Twice and plus 1 second bracket, just first term and last term. A, how many a here? Twice and plus 1 into a, and d will be common, 1 plus 2 plus dot dot n, sorry, twice n, this will be plus twice n. Okay, so we can write twice n plus 1 into a plus d into, this is the series. How many term will be there? N into n plus 1 by 2. this divided by what? Twice n plus 1. So twice n plus 1 into a 2 cancel plus d n into twice n plus 1 divided by twice n plus 1. This equals to what will be? Twice n plus 1 will be common, a plus and d. So arithmetic mean equals to what? Only a plus and d. This is the equation number 1. Okay. Now absolute value, absolute deviation of the observations from mean. Now absolute observations from mean are and d and minus 1 into d and minus 2 into d dot 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 and minus 2 and minus 3 and minus 4 and minus 4, and in this way and minus 2 d and minus 1 d and d. So absolute observations from mean, absolute deviations, this will be deviations from mean. Okay, deviations of observations from mean. That means what? First term will be what? A plus and d minus a plus and d minus a plus d. What will be? And d. And so and minus 1d, and this minus third term will be this one. In this way, this minus last term what will be? And d. Okay, remember it. And their sum equal to, can be written as nd plus, their sum can be written as nd plus n minus 1 into d plus n minus 2 into d plus dot dot plus what will be? Again n minus 2 into d plus n minus 1 into d plus nd. D common, n into n minus 1 n minus 2 plus dot dot plus 1 plus dot dot n minus 1 n. So how many n here? Twice n. How many n minus 1? 2 n minus 1. So 2 times. 2 will be common. N plus n plus 1 n plus 2 dot dot how many? Sorry, n minus 1. This will be n minus 1 n minus 2 plus 2 plus 1 in this way. So this is the actually sum of n natural numbers. So twice d, this equals to twice d into what will be? N into n plus 1 by 2. 2 will be cancelled. So we get what? Nd into n plus 1. And into n plus 1. and into n plus 1. So mean deviation, therefore mean deviation what will be? Mean deviation from mean equals to what will be? nd into n plus 1 divided by twice n plus 1, total number of observations. Okay, this is the mean deviation from mean. Now variance. Now variance will be, now variance equals to what will be? 1 by twice n plus 1 n square d square plus n minus 1 square d square plus dot plus n minus 1 square d square plus n square d square. This equals to d square will be common, n square d square how many? 2 times. So 2 d square will be common, divided by twice n plus 1. We get a series like this: n square plus n minus 1 square plus n minus 2 whole square plus dot dot plus 2 square plus 1 square. Okay, and this is another series of sum of squares of n natural numbers. Sum of squares of n natural number what? N into n plus 1 twice n plus 1 divided by what? 6. So we get 6 and 2 cancel, 3 we get, and twice n plus 1 twice n plus 1 will be cancelled. So we get only d square n, this equals to d square n into what will be? N plus 1 by 3. Okay, so this is the value of variance. Variance means you must know s square. So s square equals to this. So standard deviation s equals to what will be? Root over this. Okay, d into root over this one. Okay, because variance is the standard square of the standard deviation. Remember it, variance is the square of the standard deviation. Now we are to show that s is greater than what? Mean deviation. Standard deviation is greater than standard deviation is greater than mean deviation. Okay, so mean deviation is this and standard deviation is this. This is equation number 2 and this is equation number 3. Okay, so from equation 2 and 3, equation 2 mean deviation and equation 3 what? Standard deviation. From 2 and 3 we, from 2 and 3 what will be? S square, suppose mean deviation is greater equal to mean deviation. S is greater than mean deviation. So from these two equation, S square greater to ME whole square. S square means what? D square n plus 1 by 3 greater equal to what will be? ND n plus 1 divided by twice n plus 1. What will be? Whole square. From equation 1 and 2 and 3. Remember it. So d square will be cancelled, and twice n plus 1 whole square, twice n plus 1 whole square is greater than what? This will be greater than, by cross multiplication we get thrice n into n plus 1. 1 n plus 1 will be cancelled, 1 n will be cancelled, so other n from n square will be exist, or a plus b whole square formula 4n square plus 4n plus 1 greater than thrice n square plus thrice n. So from this we get 4n square minus 3n square, what will be n square? 4n minus thrice n, what will be n? Plus 1 greater than 0. Which is true? Which is true? That means for any non-negative integer, that means positive integer, and this inequality is true. That means we consider that standard deviation is greater than what? Mean deviation. So our statement is true. Proof. And this is the proof of our theorem 5. If you do practice, I hope you can understand this theorem. Okay, thank you. Best wishes for you. Someone may not give the attendance. Any left? Anybody left?
Sir, attend.
Anybody
Sir.
left for attendance?
Sir, আমি sir attendance
Rule number 1. Rule number 1.